In statics, we dealt with balanced forces. This means the body is in equilibrium, and the corresponding equation is sum of all the forces equal to 0. In dynamics, we deal with unbalanced forces. We know from Newton's second law, a body will accelerate when it is subjected to unbalanced forces. Kinetics is a study of relations between unbalanced forces and the change in motion. This leads to the famous equation F is equal to ma. This is also known as the equation of motion. Verification of this equation is entirely experimental. In order to understand the subject of dynamics, it is absolutely essential that you develop a fundamental understanding of this equation. Don't just memorize it. Anyone can do that. Understand the meaning behind these equations. To develop a better understanding of Newton's law, you can perform a simple experiment at home. Consider a particle and apply an unbalanced force on it. If you apply a known force on a body, then you can measure the acceleration. Using the known and the measured values, you can now determine the ratio of applied force to the measured acceleration. Repeat this experiment by subjecting the same particle with different forces and measuring the corresponding accelerations. Do this as many times as you want, and you will find that the ratios are all the same number, a constant. From this experiment, we can conclude that this constant must be some invariable property of the particle. This property is the inertia. It provides a quantitative measure of the resistance of a particle to change in velocity. We call this mass. And from this, we can conclude F is equal to ma. With an understanding of this equation, we can now look at ways to solve kinetics problems. As you can see, in both statics and dynamics, the left-hand side of the equation, which represents sum of all the forces, is the same. To account for all forces on the left side of the equation, we need a good free body diagram. Drawing a good free body diagram is the single most important step in solving mechanics problems. And the process of drawing free body diagram in dynamics is still the same as in statics. We will look at an example in our next video.